I was wondering, I think you've probably mentioned a bit of this before, but how do you use computer sciences in biology?
Like now I have already mentioned how I do it with my own research, but when I was doing my master's and my bachelor's, I was using it in a different way. So when I was in my bachelor's, I was working on something called virtual screens and chemoinformatics, which means that we were trying to find different compounds that can inhibit the pathway in which different proteins are involved. So in plain terms, proteins can be crystallized. So you get the protein in a crystal, and then you can X-ray this crystal. And once you have X-rayed the crystal, you get the coordinates. As if you put the crystal in a graph, like 2D or 3D, and you get these coordinates and you upload them on a database. So then you can use this information to then create your model of the protein, so you can see how it looks like in the space, like you can create models of your proteins. And there is a specific part of a protein in which, in order to be activated, some other compound needs to bind. And there is always this model of the lock and key. So the protein might look like this, and the other compound needs to go here. So the shape of this compound needs to actually fit more or less that area, because this means that it's going to be like, like you have your lock, you have your keys, it's going to go in, right? So that's what happens with this compound. So this compound is going to go here, then it's going to bind with the protein. The protein is going to try to, grow up, and then the conformation is going to change. And the moment that the conformation of this protein changes, it triggers something in your metabolic pathway. It can be anything, like you can be expressing other proteins, like maybe there is some glucose that it has to be digested, so you trigger the digestion of your glucose, let's say, or you have to degrade it. So, depends on whatever pathway you're trying to tackle and the protein that you're trying to inhibit or activate. It can go both ways. So I was trying to find different compounds that could change the way that they displayed on the space, so their conformation could change. And I had a target protein that was involved in some kind of cancer. And what I had to do was to try to find, by virtually modeling this protein and these compounds and this conformation, how they would go here and how they would better fit onto this protein, so they bound to it and they changed the conformation and they inhibited it. That was my main goal. So I had to do this by coding everything and then trying different compounds, seeing which compound was the best for that protein, which compound best inhibited the protein. And then I didn't have time to test it, because normally what you do is like, okay, you are trying to test as many compounds as you can, and then you're going to try to validate their function in the lab. But I didn't have time to do that. So yeah, so it depends on the field that you are. You're going to be using computational tools in a different way for different biological processes. In my case, other people might have other